Okay, we're back. This is going to be a video about completing the square, only this time I'm going to be teaching it using examples. So I have two examples here. All right, so we're going to solve this using completing the square. And the first thing you're going to want to do is get all the terms with x's in them on one side and put everything else on the other side. So for this right here, this minus 5 doesn't have an x, so I'm going to put it on the other side by adding 5 to both sides. So this is going to cancel, and you'll end up with x squared plus 4x is equal to 5. Okay, from here, we want to use the principles that were learned in the previous video of completing the square. So you're going to take this b term, divide it by 2, and then square it. So it's 4, divided by 2 would be 2, squared would be 4. So you end up with a plus 4 added here. Now because I added 4 out of nowhere to one side of this equation, I need to equally put this plus 4 on the other side. So I'm also going to put a plus 4 over here. What you do to one side, you equally have to do to the other. That's what this equal sign forces us to do. So you end up with x squared plus 4x plus 4 is equal to 9. Okay? From here, we want to use our rules of factoring to figure out what kind of perfect square this factors into. So we need a number that will multiply to get this 4 and add to get this 4. So that would be 2 and 2, so you would end up with x plus 2 times x plus 2 is equal to 9. So I just factored this out. To simplify this, you can do x plus 2 squared is equal to 9. Okay, now to solve for x, all we have to do is get rid of this squared up here by doing a square root. So I'm going to square root this side, square root this side. I mean, based on the square root property, you have to add the plus and the minus. Then you end up with x plus 2 is equal to positive or negative 3. Okay, so from here, we need to subtract off the 2 from both sides. That cancels, minus 2 on this side as well. And you end up with x is equal to positive 3 minus 2 and negative 3 minus 2, because it's a positive and a negative 3 here. So you have positive 3 minus 2 and negative 3 minus 2. So you end up x is equal to, in this case it's 1, and then in this case right here, it'd be negative 5. So those would be your two answers for x for this problem up here. So what we can do is we can back solve and see if 1 and negative 5 work. So if you have 1 squared, it's 1, plus 4, so we end up with 1 plus 4 is 5, minus 5 is equal to 0. And that works out. So our 1 checks out. Let's try our negative 5 now. With the negative 5, you end up with 25 plus negative 20 minus 5. So this plus negative 20, the 25 plus negative 20 would get you 5, minus 5 would get you 0. So the negative 5 checks out, and the completing the square worked. Okay, let's do another example, and this time the a is not equal to 1. In this case, it's equal to 3. So what you're going to want to do is you're going to want to try to divide off that 3 to make your life a lot simpler with completing the square. So what we're going to do is divide each of these terms by 3, and what you do to one side, you have to do to the other. So I'm going to divide the 0 by 3. Then you're going to end up with x squared plus 2x minus 5 is equal to 0. So now it looks a lot like the problem over here. So what we need to do is get rid of this 5. So I'm going to add this minus 5 to both sides. This will cancel. You'll end up with x squared plus 2x is equal to 5. Now based on completing the square, we need to divide this by 2 and square it. So 2 divided by 2 is 1, squared is 1. 1 squared is 1. So we end up with a perfect square here is equal to 5. But remember, if you add a 1 out of nowhere here, you also have to add a 1 over here. So you're adding this one, you have to add this one. Then you end up, if you factor this out, you will end up with x plus 1 times x plus 1 is equal to 6. Simplify this out, you end up with x plus 1 squared is equal to 6. Get rid of the square root by squared by square rooting it, and you have positive or negative square root of 6, and you end up with x plus 1 is equal to plus or minus square root of 6. Subtract off 1 from both sides, and x ends up being positive square root of 6 minus 1 and negative square root of 6 minus 1. So these would be the two answers for this problem up here. So now what you're going to want to do is test each of these to see if they actually work out. Now I'm going to leave that up to you just because it's good practice for you to try that. So try plugging these back in and seeing if you get 0. So that's completing the square using 2 examples. If you have any questions on anything in this video, let me know.